Hi guys, welcome to the today's session of design and analysis of algorithms. In today's session, we are going to discuss about fundamentals of data structures. Data structures are essential components of computer programs and algorithms. They provide a way to organize, store, and manage data efficiently. Understanding the fundamentals of data structures is crucial for designing efficient algorithms and for solving a wide range of computational problems. Coming to the definition of data structures, how we will define a data structure? A data structure is a way of organizing and storing data so that it can be accessed and manipulated efficiently. We are following a specific structure to organize our data and to store our data, which makes accessing and manipulating of the data easy. Data structures provide a logical and mathematical modeling for data management. Now we are going to see different types of data structures that we have. Here you can see the diagram which shows primarily the data structures are divided into two categories: primitive data structures and non-primitive data structures. Coming to primitive data structures, again it is represented as four categories: integers, real values, characters, and Boolean values. Coming to non-primitive data structures, this is divided into two types: linear data structures and non-linear data structures. Coming to linear data structures, this is of four categories: arrays, linked list, stacks, queues. And coming to non-linear data structures, these are of two categories: trees and graphs. Now we will see the details of each and every type of these data structures. First of all, what are the primitive data structures? Basic data types provided by the programming languages such as C, C++, Java, Python, etc. are to be called as primitive data structures, which are nothing but integers, which is used to represent integer values, floating point numbers, which are used to represent real values, characters, which are used to represent the individual characters, booleans, which are used to represent true and false values. Coming to non-primitive data structures, the non-primitive data structures are also called as complex data structures, which built using primitive data types, and these are organized in various ways. The examples of non-primitive data types, data structures are arrays, linked list, trees, graphs, stacks, queues. In queues, we have priority queues, circular queues, etc. Coming to the different types of non-primitive data structures, how we can define arrays. Array is nothing but collection of homogeneous data which are present in continuous locations. Linked list is nothing but a sequence of nodes, each containing a data and a reference point to the next node. Stack is to be called as a last in first out linear data structure, which is often used for managing function calls and undo operations. Queues. Queue is a first in first out linear data structure which is suitable for tasks like scheduling, managing, etc. Trees and graphs both are non-linear data structures. Arrays linked lists, stacks, and queues. These are linear data structures, whereas trees and graphs are non-linear data structures. Trees are nothing but a hierarchical data structure with a root node and child nodes, which is used to represent a hierarchical data representation. Graphs. Graph is nothing but a collection of nodes and edges, which is used to model complex networks and complex relationships. In our day-to-day life, we are using Google Maps. That Google Maps itself is nothing but a network which is represented using graphs. Coming to operations on data structures, we can implement various operations on data structures for doing the manipulation of the data which is stored in those data structures. The operations include insertion, deletion, searching, traversing, access, and update. From the names itself, it is clear that insertion means adding a data to the particular data structure. Deletion means removing the data from the data structure. Searching means finding the data within the data structure, whether the data is present or not. Traversal means visiting and processing all the data elements which are present in that structure. Accessing means retrieving the data which is present at a specific location within that data structure. Updating means modifying the data which is already existed in that particular data structure. These are all the various operations that can be performed on data structures. I hope that you all understood the fundamentals of these data structures. Here we explained about what is a data structure, what are the various types of data structures, what about various operations that can be implemented on data structures. I hope that you all understood these fundamentals of data structures. With this topic, we completed the 5 topics of first unit, which are nothing but introduction to algorithm, next role of algorithms in computing, next problem solving, algorithmic problem solving in computer science, next different types of algorithms, next fundamentals of data structures. We'll meet in the next session to explain about the topics which are present in second unit. Thank you for listening.